Bonjour, hello. My name is Nicolas Pocard. I'm the Vice President of Marketing and Strategic Partnership for Ballard Power System. We are thrilled to be sponsoring and participating to the Zero Emission Bus Conference. Now, with the strong support of the federal government, it is time to deploy zero-emission buses at scale across Canada. There are choices to be made, and we have the opportunity to invest in public transit while addressing climate change with a Made in Canada solution and technology. I thank you for taking part of this event and making zero-emission transit a reality in Canada now. Thank you. Merci.
Hello. Well, it's a great pleasure to be sponsoring this special session about fuel cell electric buses. As you know, we started this journey more than 20 years ago at Ballard, and maybe some will argue maybe a little bit too early. At the time, there was no optimized electric drivetrain, batteries were not suitable to be integrated into a bus. But during those 20 years, we have proven that fuel cell technology works, that it can be used in transit. Today, there are over 1,300 fuel cell buses operating in cities worldwide powered by Ballard technology. We have accumulated a unique road experience, reaching now 88 million kilometers in service for buses on truck to guide the development of our latest product platform. We have shown that fuel cell can last over 30,000 hours in operation with no degradation in the buses which operated in London. And now we are making the technology affordable so it can be deployed at scale across Canada. We have an ambitious but yet realistic plan to reduce the cost of fuel cell stack by 70% by 2024. And we are on track to deliver on our plan. We strongly believe that fuel cell electric buses are well suited for the Canadian challenging conditions and offer a complement to battery electric buses in order to achieve 100 zero emission transit in Canada. I encourage transit agencies and bus operators to look beyond the first 5 or 10 buses, but look at a depot fleet conversion or fleet conversion to see how hydrogen could provide a competitive, scalable, zero-emission solution for electric buses. The other electric bus, powered by hydrogen, produced with Canadian renewable energy. Thank you, and I wish you a good panel discussion.
Thank you so much, Nicolas. It's always a pleasure having your support on this journey. With that said, I'd like to welcome you all to the first Fuel Cell Bus panel for the day and for the 3rd annual Low Carbon Smart Mobility Conference. Well, mine first, and yeah, I hope you're loving it, be it your 3rd annual conference or the first one. That said, Today's panel is titled Decision Drivers for Integration of Hydrogen Solutions in Transit. Now, before we delve deeper and start discussing, I'd like to highlight a critical area of commitment for CUTRIC, gender parity in transit. We're actually running a national survey to assess gender parity throughout this conference. Now, in the Canadian transit industry, research clearly shows there's a stark difference between the number of women in senior leadership positions compared to men. We know these disparities exist, but we're less clear on why they exist and why they continue to persist. At CUTRIC, one of the ways in which we have committed to gender and racial equity is to translate our efforts into research partnerships such as this one with the University of Windsor. It's allowed us to engage in learning more about complexities of different workplace environments across the country. Now, to increase the number of women in senior leadership positions, we need to understand the experiences of all individuals with different identities who are also currently working in transit, so that we can make informed decisions and recommendations for transit organizations about best practices, policy, and strategy. So with that said, today, we'd also like to invite you to complete a short online survey to learn more about the social and organizational context that you work in. It will really help us assess what some of the drivers of gender parity are in different parts of Canada, in different transit agencies. The survey is open to anyone in any role, whoever works in the transit industry in Canada. By the way, it's also anonymous. We do not ask for your name or your organization. And we'll be sharing back the findings of our research in the fall of 2021. If you have any questions about the survey or research, please contact the research team at UWindsor, who are listed in the survey link. And my colleagues here will shortly drop in the survey link for you to go and fill out the survey. We welcome any questions regarding this later as well. But with that said, let's move on to the panel. We definitely have an exciting panel ahead. Now, a bit of a background on the panel first. We've had historical challenges in Canada when it comes to deployment of fuel cell buses. 2010, the first deployment of fuel cell buses in Whistler. Those buses ran in challenging conditions, and they successfully operated in those conditions. That said, we have to remember that we've come a long way. It's been 10 years. The newest generation of buses and fuel cell stacks, combined with local green hydrogen sourcing solutions, they've changed the game, and we're all ready to welcome hydrogen back to Canada now. It's pretty much a homecoming for hydrogen back in Canada and across North America. And so that said, I have panelists today in this session who will discuss what drove them to reconsider integration of hydrogen solutions at their transit agencies. Who are these panelists? I'd like to invite Darren Ridings from the city of Mississauga. Darren is Senior Manager of Transit Maintenance at MyWay. We also have Erin Cook, who's Project Manager of the Bus Electrification Program at Winnipeg Transit, yet another Canadian transit agency leading efforts in fuel cell buses. And I also have Jane Sullivan, who's Director of Grants and Governmental Affairs at Champaign-Urbana Mass Transit. Jane's also leading a very interesting pilot at Champaign-Urbana. We will hear out all our panelists, starting off with Darren, but then we will take some time to answer audience questions. With that said, without further ado, Darren, the floor is yours. The floor is yours.
Okay, thank you, Samna. Good afternoon, and thank you for the opportunity to present here today, and I hope everybody's enjoying the conference. As Samna said, my name's Darren Ridings. I'm the Senior Manager of Transit Maintenance at MyWay, and today I'd like to talk about MyWay's journey to a fuel cell electric bus trial and decision drivers for integration of hydrogen solution in transit. First of all, an overview of MyWay's fleet and facilities. So MyWay's fleet mix consisting of 511 buses, predominantly powered by clean diesel engines. In fact, 93% of the fleet is solely diesel powered, while only 7% of its fleet is hybrid electric, yet still powered with a smaller diesel engine or genset. We operate out of 2 locations in Mississauga, headquarters being located at 975 Central Parkway, housing 411 buses with indoor parking, and our satellite terminal at 6780 Professional Court in Moulton, housing 100 buses with outdoor parking. In 2019, Council approved the city's Climate Change Action Plan, which outlines clear goals and objectives in the plan to reduce GHGs across the city. It also depicts the city's focus on making every effort to positively affect climate change, of which MyWay has a lead role to play. The targets set are to reduce its emissions by 40% by 2030 and 80% by 2050 compared to 1990 levels. For MyWay to reach these milestones, we need to start our transition to zero-emission fleet no later than 2028, and any buses purchased before 2028 must be at a minimum of a second-generation hybrid. Transit buses in the city contribute to roughly 70% of the city's GHG inventory, roughly 52,000 tons of CO2 from buses alone. In 2019, pre-COVID pandemic, MyWay consumed roughly 20 million liters of diesel fuel and traveled 37 million kilometers. So with this, MyWay needs to look at alternate fuels to reduce its carbon footprint and to reach the Climate Change Action Plan targets. So around us, there are many battery bus trials currently being implemented and studied. What isn't being trialed is hydrogen fuel cells, in which here at MyWay, we believe they present a viable solution to transit. Hence, the Pan-Canadian Hydrogen Fuel Cell Bus Demonstration and Integration Trial. The project purpose is to operate 10 New Flyer fuel cell electric buses fueled with local green hydrogen within the city of Mississauga. There are 2 phases to this project, and currently we're in phase 1. Phase 1 is a feasibility study to assess viability of introducing this technology into our fleet, which will be concluded by Q2 of 2022. Bus procurement and specifications finalized by second quarter of this year, and then the purchase of 10 fuel cell electric buses by the fourth quarter of this year for a 2022/2023 delivery. Project partners working along with us are Cummins, Enbridge, Ballard, New Flyer, and of course CUTRIC. So why does hydrogen work for Mississauga? Well, comparing other zero-emission options such as battery electric bus with fuel cell electric bus, a couple of considerations need to be discussed. Energy for FCEBs and infrastructure requirements. MyWay would need electrical infrastructure such as substations to support the load demand, as we currently do not have the energy capabilities at either of our facilities. So depot charging would be a challenge. We also do not own any of our en route infrastructure, such as terminals or stations. So opportunity charging on the street is extremely limited and problematic. Range anxiety. In review of our current run guides, a 40-foot battery electric bus only allows 47% of our routes to be serviced, and only 9% of our routes with a 60-foot bus. Conversely, a 40-foot fuel cell electric bus with a range of 560 kilometers on a single fill, using a 37.5 kg tank, more than enables our complete route system and with expandability. Fueling strategy and emission reductions. Fueling time for a fuel cell electric bus is comparable to diesel, while battery electric bus, in which MyWay would have to adopt the depot charge model, is in the 4 to 6 hour range. With fuel cell electric bus, the reduction of GHGs is in the 90% range, and a more exact number will be provided during the phase 1 of this study. And as I said earlier, other battery electric bus trials are going on in the GTHA, such as at TTC, Brampton, York, Kingston, Guelph, to name a few. So as a trial, we will be conducted in our Malton facility, which is an outside parking facility. We will gain knowledge on using fuel cells in sub-zero temperatures, and other transit agencies will gain from our learnings and experience. Useful life of hydrogen fueling infrastructure exceeds the useful life of the buses, enabling the possibility of adding more fuel cell buses to the fleet without the need for adding more fueling infrastructure, i.e. completely scalable. Enbridge Cummins are supplying tube trailers and fueling dispensers at our Malton campus, which will also be outside and open to the elements. And finally, we are fostering and developing skills and expertise, as well as boosting development of local green hydrogen production and consumption hubs. Mississauga and its partners will be leading the green hydrogen ecosystem from creation to consumption, and thus reaching its targets within the city's climate change action plan. Thank you very much, and I appreciate the opportunity to present today.
Thank you so much, Darren. It's a great insight into the MyWay context, especially when it comes to championing fuel cell bus deployments in Canada, alongside Vintech Transit as well. That said, I would like to invite our next panelist here, Jane Sullivan from Champaign-Urbana Mass Transit, to shed some light on a different kind of a context and a different kind of a demonstration model for a fuel cell bus deployment. Jane, the floor is yours.
Hi, everyone. Thanks for having me today. I'm going to jump right in and start by telling you all about our mass transit district. We are in the Midwest United States in central Illinois. We are located alongside the University of Illinois College campus. So it's a very typical college town, and we cross two cities, Champaign and Urbana. You can see our ridership up there. That's pre-pandemic ridership. The past couple of years before the pandemic was between 12 and 13 million rides a year. You can see we have 114 buses, and most of those, almost all of them, are diesel electric hybrid buses. And the university has about 55, I think now, 55,000 students. So we, just getting back to the fleet a little bit, we started in 2009, we started to convert our fleet to hybrid. Every bus we purchased starting in 2009 was a diesel electric hybrid. And now we have our first zero emission buses. And these are our hydrogen fuel cell buses. So this gives you a little bit of an overview of our project and also kind of a timeline. So we think of our hydrogen fuel cell bus project as having 4 parts to it. We have had to make some modifications to our maintenance facility. We have indoor storage for our buses in Illinois, and as I mentioned, we only had diesel and diesel electric hybrid buses, so we didn't have CNG or anything, so we needed to make some changes to ventilation and detection. We actually had to build some walls in the facility that stores and services all of our buses. So that was kind of the first part of the project, and then the vehicle piece of the project is 2 60-foot articulated New Flyer fuel cell buses. And you can see we have our partners listed up there, our friends Ballard, who I know are with us today, and others. And the third part of our project, which is underway and nearing completion, is we are building an on-site hydrogen production and fueling station. I'll talk a little bit more about that. And then we are also installing a solar array, and I'll talk more about that as well. Just maybe I should talk about the timeline a little bit more before I move on. As I mentioned, our facility modifications are complete. Our 2 buses are on site, and we are completing the testing right now. They aren't in service yet, but they're here and they're running, and we're just going through some testing. And then, as I mentioned, the construction of our hydrogen station is underway. It's scheduled to be complete in September. And we just last month awarded a contract for our solar array, so construction should start in about a month or so. Okay, here are some just basic specifications on the buses that you can see up here. We always get the question of fuel efficiency, which I just can't speak to yet because these buses haven't run in our environment yet. But you can see some of the other specifications we have. And I'll talk about our main drivers for choosing hydrogen fuel cell for our first endeavor into zero emission vehicles, and then I'll get a little bit more specific on the project elements. So as you can see up here, we had 3 main goals. We wanted zero emission vehicles, we wanted to reduce our fossil fuel consumption, and this one I would argue is the most important to us. We wanted minimal operational impact. So I'll talk a little bit about our hydrogen production station. So what you're looking at here is a photo from above, from a drone we had flying over the station, and this was a couple weeks ago. So we've made a little progress since then, but that progress actually isn't as visible. This was right after most of the equipment was set. So we have an electrolyzer here. We have over 900 kilograms of storage. There's compression and lots of cooling. And then the hydrogen runs what looks like on your screen to be up out of the shot of the photo to where our fueling station currently is. So we currently have an outdoor, just not very far from this, an outdoor, we call it a fuel line with 2 diesel fuel pumps. And so we are installing 2 hydrogen fueling pumps just right in line with that. The main reason we wanted to produce the hydrogen ourselves on site is because we do not have a source at this point in where we are located in Illinois for renewable hydrogen. And it is very important to us that we are not using fossil fuels and that the hydrogen is truly clean and green and renewable. And so we had also an opportunity, the stars kind of aligned, and we had an opportunity to lease some land just across the street to build this solar array. And so there will be a direct connection between that solar array and the production station you just saw. Okay, so talking about the minimal operational impact. Sorry, this is in miles, but what you can see here is the red box is all of the routes that day that would not have been conducive to a battery electric bus, we believe, for example, that doesn't have the same range as a fuel cell bus. So right here, that's really our biggest decision maker. We did not want to deal with changing routes, with adjusting schedules based on charging times, with coordinating en-route charging. We had no interest in that, and we wanted buses that would run just as long as our hybrids and our diesels do. You can see a little bit of our near-term plan for adding to our fuel cell bus fleet, and we when we talk about the decision between battery electric and fuel cell, we like to show this graph and how there is a bigger upfront cost and effort for fuel cell, but it does scale really well as your fleet increases. Okay, I think I'll stop there. I look forward to chatting with you all and taking questions later. Thank you.
Thanks a lot, Jane. That is definitely a very different context and project scope compared to some of the cases we've seen here. So I'm looking forward to some comparative discussions on that. That said, I would like to welcome a final panelist, Erin Cook from Winnipeg Transit. Erin, look forward to hearing about your plans and what has been driving your decisions in this space lately.
Thank you, Samya. I am Erin Cook, the project manager for bus electrification at Winnipeg Transit. Winnipeg Transit is a mid-sized Canadian transit agency. We currently have a mixed fleet of 640 diesel buses. We do all of our own maintenance in-house, and we operate out of 3 garages, one of which is currently in need of replacement. We've been hit pretty hard with COVID, but prior to COVID, we were operating about 30 million kilometers per year, with a weekday passenger load around 168,000 people. We previously ran a battery electric bus pilot, and I don't want to talk too much about battery electric bus, but I think the experience from this trial is important to understand for our decisions towards moving towards fuel cell buses. Overwhelmingly, the customers enjoyed the buses. The experience was great. But there was a few issues with the technology, and some of it had to do with the fact that it was prototype technology. But the buses were en route charged buses. They need to be back at the charger every 2 hours, and the charger was not particularly reliable. So there was a lot of range anxiety with the drivers, and there was issues with the complicated charging procedure. So sometimes the buses missed charges, and we had to call buses to be towed back. What we really found is that the charger was as much of a challenge as the buses in that trial, and the availability of the charger really affected the availability of the buses overall. So overall, the buses did not accumulate nearly the amount of mileage as a battery electric bus did. And really, en route charging now is seen as an option for extending range of battery electric buses, but we found that in our case, that isn't necessarily the best choice. So a lot of, what you hear today on all of the sides is the technology challenges. Everybody knows they're more expensive, the range issues, weight issues, labor transition, and that's common across every single transit agency. But it's everything below the surface when you start undergoing your technology, ZEB rollout planning, et cetera, that you start to see the problems that are related to infrastructure. And these are all really unique to each city. So what does your electrical grid look like? What are the power at your facilities? What kind of footprint do you have available to put new technology? Are you landlocked? Do you have a new garage? And how ready is your utility to support your electrification plans? And these are all things that every city is going to have their unique challenges. And in our case, we found that a mixed fleet was likely going to be necessary to solve some of these problems. So our primary requirements for our technology evaluation was 0 tailpipe emissions. So when we started this, there was a lot of conversation around, zero tailpipe is one thing, but what's the life cycle impact of batteries? And these have much bigger batteries than cars. So we did a life cycle analysis to see what the impact was. And we found, despite the scale of the batteries, that 2.5-year payback really was applicable to buses as well as cars. And all of the options that we looked at were at least 40% fewer life cycle emissions than a diesel bus. And most of the ones were closer to 80 to 90% life cycle reductions. And then I wanted to sort of quantify some of the decisions on our side here. So once we had decided that, you know, our study was going to look at rapid charge buses, long range buses, and fuel cell buses, we really sort of wanted to rank what was important to our transit agency. And this is just kind of one example, and every transit agency here is going to have a different sort of ranking system and a different scoring system as well. But what we found when we looked at, you know, the importance not just of the cost of the fuel, purchase price, maintenance, but also the operational impact. So how good was the service or the technology for high frequency service? What was our grid limitations, range, flexibility, et cetera? And we found that long range buses and battery electric buses were really competitive with each other, and were, you know, a little bit ahead of the rapid charge technology. So digging in a little bit deeper, life cycle cost of the buses here. When you looked at a pilot, and this is a lot of the times why nobody moves beyond a pilot with fuel cell buses, is the cost of the infrastructure is just so high. The bus price is high. But when you look at your study and are looking at life cycle costs of the buses and what it would cost to replace your entire fleet, there's that range really comes into play in terms of what your fleet is going to look like. And, you know, you're looking at potentially 10% more buses for en route charging, 6% for long range, and fuel cell buses are almost a 1-to-1 replacement for diesel. So, you know, your smaller fleet size starts to offset the cost of the buses as a total fleet price, and that infrastructure cost per bus really does come down. So all those things you had to do one time to get your fleet up and running, like facility updates and whatnot, those are one time. So when you're looking at the fleet cost and the fact that you don't have to do backup power necessarily, the capital cost of the bus really comes down. So then it really just comes down to the cost of the fuel itself. And, you know, depending on, you know, where your hydrogen's coming from and how the cost progresses over time, fuel cell buses could end up being the most expensive or the least expensive option. Here we found with the fleet mix that we're looking at, with our mix of 60-foot and 40-foot buses, the break-even point of the target price was around $4 per kg. And we found through our cost analysis that on-site production was really the only option for us that came close to that price point. And one of the reasons that we're looking at for fuel cell buses really had to do with our network specific ideas. So we have a primary network that's high frequency service, typically with heavily loaded buses, 60-foot buses, 40-foot buses in higher frequency. And then we have a feeder network that's our depot charging or en route buses might work because they're not as frequent. They, you know, cycle every 20, 30 minutes, shorter runs, etc. But that primary network really didn't work for en route charging because of the high frequency and the need to charge those buses, you know, for 10, 15 minutes. That isn't acceptable for our service that we're trying to target for 5 to 15 minutes between buses. And for our case, we've already done a pilot of 40-foot buses, and we wanted to include 60-foot buses in our trial. And 60-foot buses are significantly superior in fuel cell as an en route charger than en route charging with overhead pantograph. Some other things to consider is power limitations. So when we looked at what the power requirements were going to be for charging or hydrogen production or delivered hydrogen, there's huge economies of scale that change. So with delivered fuel, you're running compressors, you're running your dispensers, and the power requirement is pretty low even when you're looking at 650 buses. But that jumps substantially with charging and even with en route or producing fuel on site. In our case, you know, we have a landlocked facility that only has 3 megawatts of power. So looking at options for electrifying an existing garage with 3 megawatts of power, charging at the depot just doesn't make sense. And as we explained before, en route charging didn't make sense. And so fuel cells are the key solution for some of those garages that are more difficult to plan for. And the overall conclusion of our study was that fuel cell buses have significant operational improvements. So fast fueling, simplified scheduling, low capital cost investment. If you can get delivered fuel, minimal backup costs, resiliency, during outages, power outages, and really battery electric buses only had the advantage of a stable fuel pricing for cost of electricity. So what we ended up with was a mixed fleet, as I discussed, and right now, based on where the technology is at with both fuel cell and battery electric, we're looking at probably 30% fuel cell and 70% battery electric. But we are going to sort of prove this out during our trial and see, what the real cost of operational convenience are for fuel cell versus the fuel price of the electricity. So those are the things that we're really looking to study, as opposed to just the technology of the buses themselves. And this is going to bring some unique challenges with having to manage multiple procurements and adapting your workforce to do different technologies. But really, we have to start scaling up to zero emission really quickly. So we know it's going to be a little bit painful at first, but putting a trial that's going to include both types of buses, multiple length, is really going to help us accelerate our transition much quicker. And the plan that we've developed is flexible, that if we need to go faster, we can. But we're definitely going to meet our targets right now of zero emission fleet by 2050. All right, thank you for your time.
Thank you so much, Aaron. Some great insight there into the bus electrification plans at Winnipeg Transit. I'd like to invite all our other panelists now to have a bit of a comparative discussion and get a bit of a deeper insight into their plans. I guess one of the striking differences in all your presentations was the scope. The scoping decisions differed at each of these transit agencies. How many fuel cell buses to be deployed as part of an initial demonstration, and what kind of a fueling solution we're going to have as part of these demonstrations. Now, yeah, I understand, Aaron, you didn't delve too much into those details, but would love to, have a bit more insight on that too. But so yeah, to start off with Jane here. You did highlight a bit on your plans going forward, from 2 buses to 6 buses and so on. And you also highlighted, why the on-site hydrogen fueling solution, right? Looking at these decisions right now, how do you see the trajectory shaping up for especially your fueling infrastructure, right? Are there going to be substantial incremental capital costs, or is your current scoping decision going to accommodate scaling at minimal incremental costs, you think?
Yeah, the station we are building right now, it will be built to accommodate up to 12 buses. So we have room to grow with the current infrastructure, and we should not have to put more capital into the station, just some vehicles. And there is also physically room to expand. If you recall from that picture on the left side, there's some open space, not too much, but we did intentionally leave that open so that we could expand the station. We're actually right now doing some work to figure out what it will take in terms of space and dollars to expand the station beyond 12 buses. We would like to add another electrolyzer and storage and expand production if that's feasible. But there is also a likelihood that we will take delivery and supplement our production with delivery of hydrogen eventually. So the station will accommodate our near-term bus procurements, and we'll kind of see what happens. I should also mention the calculations show that the solar array is sized to provide enough power for the needs of the station as it will be in this first phase, fueling up to 12 buses. We should have enough solar energy to produce the hydrogen to fuel up to 12 buses. So there will also be, if we expand the station, also be conversations about expanding our solar energy or other renewable energy.
That's great to hear. So from what I understand, there is substantial capacity when it comes to the input for hydrogen production, but then it's ultimately it's most likely going to be the space constraints at the bus depot, not in the immediate future, but potentially in the future. And so I heard you mention delivered hydrogen at some point, and so going to Darren here, looking at the fueling system scope for the demonstration trial at MyWay. Darren, can you please shed a bit more light on, first of all, what's the configuration of the chosen fueling solution, and how suitable it is to scale at minimal capital expenditures in the future?
Okay, great. Well, I mean, the fueling stations I mentioned is going to be positioned in Moulton. It's a tube trailer scenario based on consumption that we believe that we will consume, and the rate at which the hydrogen can be created and delivered. It does give us that scalability. Plus, the fueling station that is going in is built in such a way that it will allow us to expand our fleet, and no different than what Jane just mentioned. It would be pretty much the purchase of buses, not additional fueling infrastructure to support the additional buses.
Sure. Thank you, Darren. And a final bit of a comparative insight from Aaron's point of view. Aaron, would you like to shed a bit of light on your fueling configuration? What drove those choices, scaling paths?
Sure. We've also gone with on-site production with about a 500 kg per day electrolyzer. And that was, mostly driven out of the fact that we have no local source of hydrogen as well. But it also came cost considerations as well. So as a city, we have access to capital funding that helps offset some of the cost of that fueling equipment that brought the CapEx cost of it quite low. In addition to that, when we're producing the fuel ourselves, there's no markup attached to that. And we're really considering this as a test fleet, not a real integrated trial or integration of the fleet just yet. So we have, even though we have 16 battery electric or 8 battery electric and 8 fuel cell buses, we still have 630 diesel buses that we can use for resiliency. So we're right sizing our filling station and the storage based on the test fleet, and then we can scale up the storage as our fleet grows. So, we can start running the buses on weekdays instead of weekends, and you sort of limiting their mileage as they get older, not older, but as we get more comfortable with them. So, while you could run the buses full to empty every day, and, 500 kgs doesn't go very far, you're 10 to 12 buses. If you reduce the mileage and produce fuel on the weekends to use it on the weekdays, you can stretch that fuel up to about 30 buses here. And that's just based on the fact that you're probably not running the buses every single day. They're probably 90% of the time they're on the road, 10% they're going to be in for some kind of maintenance. So that's really what we did, was try to cut the cost down to keep the capital as low as possible and the production cost as low as possible, and making it right sized.
Thank you, Aaron. And so the last bit that I heard was maintenance, and maintenance is definitely one of these important issues to consider when choosing the number of buses to be deployed as part of a trial, and at the same time, just to ensure that just operating such a trial doesn't end up becoming a costly affair, right? That being said, can you please shed some light on what you considered most important for operational readiness and demonstration projects? Now, did you feel like having your staff and your workforce ready to operate some of these buses, even on demonstration trials, was going to be the most important thing to focus on initially? Or did you feel like, figuring out the ideal worst case routes to operate these buses on was more important? And I ask these questions because it influences your decisions to go for a feasibility study right away or not, right? To assess, what routes to operate these buses on. So if you can shed a bit of light on, your operational readiness decisions. I'll start off with you, Aaron. Did you feel like operations training immediately is very important?
Yeah, I think we have a little bit of advanced experience with having run battery electric buses for 4 years. So, from a driver's perspective, they know a bus is a bus. There's no difference really there, other than some safety training around that. But we've been working with our local community college to develop EV programs. And then have been in, conversations with Ballard and New Flyer in terms of, what to expect for training provided by OEMs in support of that. So, we're definitely, working on that. And we know that the rest of the things that are going to come into play are, you really can't experience, you have to experience them. You can't necessarily plan for them directly. So, we are planning for what we know, and then we're giving a little bit of buffer time for all those things that we don't know, and we plan to assess during the trial period of about a year before we make decisions on purchasing more buses or what type of bus to purchase going forward, I guess.
I believe that's how most leaders would approach something like this. Just take that leap, and planning accordingly. Is it similar at My Way, Darren? Any other operating risks that you foresee, and any operating risks that particularly bothered your decision-making process before scoping out this trial and getting into the launch phase of this trial?
Well, hydrogen fuel cell buses are completely new to us. We've got no experience with them within our fleet. So, there was a fair amount of risk there. However, working with New Flyer, who is integral part of this team, we do plan that, for the first 5 years of the life of the bus, that the maintenance will be looked after by a subcontractor. And we do plan to use that time to work hand in hand and gain that experience. And as the trial progresses, then we'll evaluate whether, come the end of the 5-year period, whether we continue on with the maintenance, or at least the drive system maybe continue to be looked after by somebody else. That will all be the outcome of the trial. But that's the way we're approaching it. As I say, it is new to us, so we're definitely in a learning curve and a learning mode. And I'm looking forward to getting them on site so we can start that journey.
Sure. And so moving over to Jane. Jane, we did notice that 92% of the fleet at Champaign-Urbana Mass Transit has been diesel electric hybrids, if I get it right? And so have you learned a lot and enough, to feel comfortable scaling much more rapidly, or is operational readiness a major concern on your end as well?
We are right in the middle of operational readiness. We haven't trained our bus operators yet, but we will start that very soon, and we have carved out a couple of months to do that. One thing that comes to mind on this topic is when the buses were being built, we contracted out to an inspector who has experience inspecting fuel cell buses, and we also sent our employees who spent a lot of time at the plant. And so our employees learned a lot before the buses even arrived on site. And that has been very beneficial. And we're a smaller agency, so it maybe is easier for that to spread, but we now have 2 in-house experts-ish on these on this technology that is totally new to us. So I think that was good. We've started training with New Flyer and with Ballard, and we'll continue that. Another thing that comes to mind on this topic is one challenge for us, because we are also building this hydrogen production station, is the timing of buses being on site and having something to fuel them with. And so that was definitely a dance we were doing and have been doing, because if you remember, our fueling station is not ready, but we have buses. So we had to work through some contingency plans, and that is a challenge if you're going this route and producing your own hydrogen.
That is interesting. And so, picking on the word of contingency planning, one of the major risks, and while we're on discussions about operational readiness and maintenance issues as well, another common theme at all year transit agencies is cold operating conditions. If starting off with Jane, if you can shed a bit of light, some quick light on concerns regarding cold operating conditions, and how you've tried to alleviate some of those risks. And I'm sure, I'm sure Nicola would love to connect with anyone having concerns about this, separately, and really run you through, fuel cell operating resilience in cold conditions. But I'll leave it up to you, Jane, for a bit of light on that.
I don't feel like I can say too much because we haven't operated these buses in the cold yet. I can just say we've been told it will be fine. We've been told they'll operate great, and so we'll see.
Yeah, no, that's a fair point, and I guess that is yet another reason, to rationalize and justify these local demonstrations sooner than later. So that we can be on our way to scaling using fuel cell buses sooner. Erin, any specific thoughts on this?
Yeah, I know the New Flyer buses run well in the cold. I work for New Flyer. I helped design those buses. So, they do capture waste heat, and they do operate the 40-foots, but there's no real data on the 60-foot buses in cold data. So, they produce about 17 kilowatts of heat, which in most parts of the country is fine. We'll see in Winnipeg when it's minus 40 how they do. And that's one of the concerns. Right now we don't think they're going to need a diesel auxiliary heater, but that's something that we're going to find out during the trial. And then 60-foot buses are a whole new story. So it'll be interesting to see data coming out from Jane's trial soon and see how those are really translating the heat capture from those buses and how it works on a 60-foot.
Sure. And Darren, any specific thoughts on this?
I'm very interested. We've had lots of conversation with Ballard, the manufacturer of the fuel cell, regarding outside parking and storage of the bus. We are going to have obviously the ability to plug them in to protect the fuel cell, especially Malton, with it being an outside facility. As for cabin heat, like Erin says, we're in the same kind of mode of understanding what heat we can scavenge. And again, this is what the trial's all about. We definitely have 4 different, I'm going to say definitely 2 different seasons here in Ontario. Usually goes from winter right to summer. So it will be very interesting as to what the trial actually uncovers. And hopefully, we don't need to go with that auxiliary diesel heater and be completely zero emission.
Sure. And so while we're on the theme of operations again, let's delve a bit into facility modifications, some more details on facility modifications. And so Darren, what kinds of facility modifications do you foresee at your bus depot before deploying these buses? Also, looking long term, what kinds of modifications do you foresee? Is there space for redundant equipment installations? Will you require any redundancies to be factored into the fueling station design and such as well? If you can shed a bit of light on that.
Sure. So there's already built-in redundancy, as I indicated in the presentation, that this is completely scalable for us. We can add additional fuel cell buses to the infrastructure that's going in place for this trial. Facility modifications, yes, we need external electrical connectors to be able to plug the fuel cell in for sub-zero temperatures. But also our molten facility, from a maintenance perspective, we have a series of bays that we've already got our partners looking into, what does it take for us to park a fuel cell bus inside a facility and be able to do work on it. Because let's face it, other than the drive system, it's a bus. It's still got all other components we all know what they are, and we're working on them currently. So, if we do need to change a simple headlight or a tire or whatever the case may be, we don't want to be handcuffed where we have to send this bus off site to do a menial task. So being able to equip the maintenance shop to be able to accept a bus to do these running repairs, and then obviously anything that's significant with the fuel cell or the drive system would be looked after by New Flyer, whether it be on site or at a New Flyer facility somewhere in the city.
Sure. Thank you, Darren. And Aaron, you did cover up a bit on your fuel supply redundancy considerations and how it impacts your facility modifications. But any other specific modifications that you can shed light on?
Yeah, like hydrogen detectors in the maintenance garage. There wasn't much required for a parking garage. So, we have to do a ventilation review to assess our facility. We're fortunate that we just built a new maintenance extension that can be a little bit isolated from our older facility, which should help on that. And then if we go beyond 30 buses, we're looking at trying to integrate indoor fueling. So that's going to require building walls in our facility to isolate our fueling lane, and some pretty major updates there just for a lighter than air gas facility. So, right now the codes and standards are kind of evolving in Canada, and every province kind of uses their own. So hopefully, I know that there is a new Canadian update to the Canadian National Standard for hydrogen that they're hoping to roll out and get adopted across country. So hopefully, by the time we really are ready to go with this, that maybe there'll be some improvements in terms of clarity on what exactly needs to be done, and then more consistency across the country.
Thank you, Aaron. And so moving on to Jane. Jane, you did mention that Champaign-Urbana has already undertaken some modifications, and if you can shed a bit of light on what they were and what the long-term plan for that is.
Sure. I think they were pretty straightforward. Again, we park all of we have one maintenance and storage facility. We park all of our buses inside, and we work on all of our buses in that facility. And so we needed hydrogen detection. We needed some improvements to our ventilation. And there were a couple sections of the facility that it actually made more sense to wall them off and keep them separate, like a mezzanine area and such. So I think out of the 4 pieces of our project, that was probably the simplest piece of the project. And again, outdoors, we added the hydrogen fueling pumps just alongside in the same lane as our diesel fueling pumps, pretty close to where the production station is.
Okay. And so, yeah, I think this takes us through some of the core capital cost components. And we've also talked a bit about operating cost components, but not as much about the key operating cost component, fuel supply. And on a final note, if we can shed some light on your concerns regarding fuel supply prices, and how do you intend to, what advice would you give another transit agency considering FCEB deployments to pacify them about fuel supply prices? Is there any advice you can pass on? Starting off with Jane, what's your foreseen trajectory when it comes to fuel supply prices, and what makes you confident that you can go ahead with your fuel cell bus deployment plans?
Well, with our setup, I'm confident that we will continue down the path of using renewable energy to produce our hydrogen. And so with our setup, we aren't as impacted by the actual the hydrogen fuel pricing. And so that helps us proceed and with confidence.
Yeah, how about Mississauga Transit, Darren?
Well, everything I've seen so far, it's the more fuel cell buses I have, the lower the hydrogen cost becomes. So, the trial is one thing, but projecting to the future and saying that the trial is going to be successful, that's when I think that we really see the ability to get closer and closer to hydrogen and diesel being at par. It's going to take, not just me, it's going to take other transit agencies to, hopefully go down this path, and our other companies go down this path, which will drive the requirement for hydrogen, which will eventually lower the price to a more palatable level. So that's where I see this space headed.
And so, speaking of palatable levels, if you can shed a bit of light on your projections, Aaron. We do understand that the fuel prices at Winnipeg Transit are likely to be based on the short-term marginal cost and not the levelized cost of hydrogen, right? And how do you see these prices moving in the future?
Yeah, like we're using grid power, and our cost of grid power is like 4 cents a kilowatt right now, kilowatt hour. So it's very, very low compared to most places. So we're able to produce at $4 a kg, but the cost of electricity continues to go up. So we're going to be rising with inflation amongst other things as well. And our ultimate goal is to get a source of delivered fuel that can be competitive in that under $6 a kg range at least. So, that's something we're monitoring, and our on-site production facility basically gives us that little bit of time to wait for the hydrogen supply chain to catch up.
Thank you so much, Aaron. And so, we're running out of time. So unfortunately, we won't be able to go through more of the audience questions, but we have another fuel cell bus panel coming up tomorrow, where we'll explore the other side of fuel cell bus deployments, the strategic importance of fuel cell bus integration, and also the value of these kinds of deployments to a particular jurisdiction. We will be taking the case of a particular project my way yet again, and we'll delve into some of those aspects of the project. And so hopefully we'll see you all again tomorrow to talk more about fuel cell buses at transit agencies. With that, thank you so much, Jane, Darren, and Aaron. I look forward to speaking with you again, hopefully at the next CUTRIC conference as well, and hopefully we'll have positive updates to share with the group here.